So why this topic is at all needed, first of all, engineering practices. That is where most of our projects fail there itself before we actually start the project. So when I started my own company called Aduza Robotics and Private Limited, we came up with the idea that yes, we should start working on some making of the robot even before India startup India and those things went so viral by our renowned Prime Minister. So that is there. So yes, we started making it. Then we thought upon what to make it, right? So what to make, then we saw all the robots are getting imported. So can we do just the import substitution? Or maybe we can think of some niche area which is still remaining. So that is where we nailed it actually. So it was parallel robot. Almost 50 to 60% of industrial robots are parallel robot where, not just robots, some machines also. It was parallel robots. So we picked in with that. We started building on it. So after my PhD from IIT Delhi, I started with my students involved projects, and then those things I started making it with them, and then gradually we started making products kind of, and we started delivering things. Now it's a established company, and we have delivered our products to almost 50% of IITs and quite a lot of NITs already. So that is where we are, and we grew in almost around 3 years by now as a registered company. But yes, as a company product owner, I am since last 7 years. So that is a brief history, means how we all started, and in during that journey, no, quite a lot of things have started actually. So I started realizing why products fail, what student projects can move on to become products. So that this talk will be mostly upon that journey only. I hope quite. So what is diversity of this group actually? May I just get introduced to you all? Not one by one. Maybe the host can tell me. So they are all from robotics community. Yes.
So they
No.
are from, so we are organizing as a part of mechanical engineering department, but
Mechanical.
yeah, they vary from first year to fourth year. So all
First
the,
year to fourth year from different branch, right, Krishna?
yeah, we do have diversity in branches, sir.
Oh, very good. Very good. So that is what is robotics is all about actually. So I am not going to give you a talk on robotics as such 100%. Okay. So this will be an intended talk which makes you a real engineer. So let's see what I have to say. So yes, so when I see our bots in different competitions, hobby level competitions, or even in science exhibition across India, no. So I have seen quite a lot of flaws there, no. So can I just name a few points which you dare to do if you really want to grow forward with any product design, product as such, not just robotics. Okay, so first thing is double-sided tape and electrical tapes. Hope you can recall all your projects or maybe quite a lot of projects in your final year BTech. Is it not? So if you can, if it can make it, this talk can be made interactive, it would be much better. I don't know how much time do I have from now? Yes, Krishna. Do I have time?
Yes, sir, you
Because
can extend the
we
session.
started late. We started late. So anyway, so yes, electrical tapes, double-sided tape. If I tell you don't use that, so if you can see all the pictures of different robots here, at least the corner, bottom corner one, no? You see Arduino board, this board is glued with double-sided tape. And you see there are so many electrical tapes which are wound there, no? So that is one of the project. Even in this one with ultrasonic sensor in the forward side of it, the battery is glued on a double-sided tape, right? And then the second culprit is your jumper wires. Jumper wires. Yes, this one. These wires with two pointed ends, no? They are known as jumper wire that connects one part of the circuit to other part. They are unsoldered wire in screw terminals. Okay, unsoldered wires, they are put in screw terminals. Sometimes they are tightened, sometimes they are just pushed in. Okay. And then you wonder where did the things go wrong, sir? It was working till yesterday, and now during demonstration just few minutes back it stopped working. So these are one of the most unreliable wires which we use for most of our projects, may it be a Robocon event, Techkriti, Technex, or maybe eYantra, or any place to name with. Okay, so you are using this. Okay, then comes cable ties. Over here it is fixing the battery, green one, no? Top left, this green robot, now there is a battery which is fixed with cable ties. It is named as cable ties. These are not to be used to fix heavy equipments like batteries which are there on board your robot or maybe any project. Okay, then comes the embedded sensors. You have multiple kinds of sensor in this robot. You can see at least ultrasonic range sensor is there in the front of this robot, the one with yellow wheels. There are many such bunch of sensors which are shown in the top right corner. Okay, so there are many such sensors which are there, and that is again a culprit. They are not ruggedized sensors. They may go faulty at times, and they are not at all reliable. So in competitions you cannot rely on that. You have invested a lot on going to the venue of the robotic competitions, and so many of you have put your time, invested your money, and yes, you have gone there first of all with the hope, right? So and you are investing in this. Okay, so this is one. Then comes actuators. Normally we use position only servo for arms also. Normally servo motors, they are position controlled, and we look for controlling even a few things like maybe rudder control or maybe fin control of a aero model or something like that. So in all those, no, we tend to use a servo motor. Is that all which is suited for everything? Okay, so that is what we should think of, and we easily, we have no option actually. We quickly choose them and we make our projects, even to make robotic arms. So why it should not be chosen, I'll come to that later. But yes, they are position only servo, and there is no essence of velocity, direction, or even torque control at times. Okay, so yes, next thing is communication protocol. Normally we use what? Anyone? Which communication we do from board to board communication? UART, serial communication, if you remember, right? RS-232 we commonly call this as. USB to serial ports we are using, USB communication, that is there for your mouse also. Bluetooth communication, right? If it is wireless, it can be Bluetooth also, or radio communication. Okay, so these are few communication protocol which again is very unreliable. So locating them, locating the antenna and line of sight, those things do matter. And yes, that also makes the project fail. So yes, and cheap and unreliable components. There are many such innumerous components that we do use, okay, to make our products, right? Products or sometimes projects, yes. So last but not the least, if I tell you not to use a hardware controller called as Arduino boards, really, can you think of any project without using Arduino boards? Have you made anyone who has made their robot without using Arduino board? Anyone here from robotics or not robotics or any mechanical, electromechanical projects? Definitely chemical people will do that. Person from chemistry or biochemistry or maybe something entirely different, not a electromechanical projects. You cannot think of a fridge, you cannot think of an maybe AC or washing machine or any machine, electromechanical machine. If I take away Arduino from your life, can you think of making a robot again? Why this has happened? This became a culprit in last 10 years, not more. Okay, 10 to 15 years maximum. Okay, so before to that, we were making robots, we were doing programming, we were using microcontroller as well. So what else? What is the alternative? That is what I'll talk about now. Okay, so these are a few culprits. Okay, hope you are listening. All of you are there. If few of you can show me your face, it would be much better. Okay, so where did you start basically before UG? Okay, before undergrad, where you were? Just check any nearby school level hobby competitions and science exhibitions. You were doing it before, right? Quite a lot of you. Hobby level science competitions and those exhibitions you all have attended, right? So you see, even kids are making robots with, you see in the front it is, what kind of sensor is this? This is
Ultrasonic
ultrasonic.
sense.
Yes, very good. And then you have wheels, you have motors, right? And then you have similar kind of maybe Arduino board or something. So that is a school kid who intends to make a maybe obstacle avoidance robot or a line follower, right? So that is very common in a school level nowadays. If you go to abroad, again you find you have Lego based line followers and kids do play with that, right? Nearby science exhibition, I have been there as a judge and I saw there is a student in India, and there are many students who do this. Yes. So this person is doing an exoskeleton, right? Links with the potentiometer joints. Joints has the potentiometer which can tell the feedback of how much angle that the joint has turned. Okay. So each joint gives you the feedback of joint angle, and he can do forward kinematics, or maybe using simple trigonometry he can find out where his both the arms are, and he transferred that values to his motherboard, which was an Arduino board, and then he had motor driver on all the joints of the biped which is lying here, right? And that fellow used to replicate the motion what this fellow was doing, and this is a school project. It was DAV Bokaro, DAV Bokaro school. So it's in Jharkhand, nearby Steel City town. Okay, so it's a DAV school, intermediate students are doing it. The project next to it, it has, you see there is a goggle which is kept here. It has a blink sensor over here, maybe a photoelectric sensor or something, which tells the status of your eye whether it is blinking or not. Okay, it takes the input to the board which is here. It counts the number of blinks per second. Okay, and at the steering at the center it has a sniffer also. Okay, if you are drunk, it will detect whether there is any alcohol presence in the air that you breathe out, and it can tell you whether you are drunk or not. So a person who is driving a car, this seems like a car dashboard with all these features which can detect whether you are sleepy, whether you are drunk, and it can give you an alarm and maybe it can halt the car. So this was a school level project again. Okay, so if this is the level of school level project, so can you imagine what we are doing then at UG and PG level, or maybe probably few of the PhDs also. Right. So this is where we came from. Quite a lot of you have witnessed this, right? During your school days also, you were familiar with Arduino and all, right? So check with the nearby school hobby competition. That is why. And if you go to a little bit higher, maybe Jilla level or maybe district level and sometimes state level or national level, you will find even more complex hobby level projects already at the school level. So that is where we came from. That is what we were before doing UG, right? And we want to pass out with the same tool set from where we have got into our BTechs or BE or BSc, whatever. Is it not? And then again, these are run by toy makers. All these businesses are of Chinese markets. Robo.in, or there are many, Vista or maybe India Mart or maybe Amazon, quite a lot of embedded kits are available, Arduino is there. So whole of these ecosystem which you see around school days, which you saw during school days, all the parts are nothing less than Chinese cheap components. These businesses are run by them. They are toy makers who tend to now become these robotic supplier. Actually, most of them do not even fit to be called as robotics project sometimes. Yes. it is worth it because it serves the purpose. It starts tinker activities among school level. It creates interest in making things. That is what we want. So this is good as long as it is school level competition. So just now I have called all your UG level project as a school level project. So quite a lot of you may be thinking, then what we will do, what tools we will use, right? So that is what is a big question. And are we still doing the same as long as we keep on using them? Have you seen any AC or a fridge or a washing machine delivered to you with an Arduino board? Or maybe any of these kind of sensors? Or maybe electrical motor that you have used in UG level? If at all you have come across, please write it in the chat box, or if you have some idea, you can put it here in the chat box, or maybe you can halt me and you can say that. Okay, so that is where we started before UG. It was good till school level. Okay, don't claim that you are still doing UG projects. Definitely you are not, if at all you are doing this. So this simple clumsy bots, where does it lead to? These are all pictures from Robocon India that is organized by Didi Durdasan. It's a biggest national level robotics competition organized. There are similar competitions organized by Technex, that is IIT Kanpur, Techtriti or Concetu IIT Dhanbad, and Srijan somewhere, and then quite a lot of names are there, technical fest. In all of them probably you have seen these kind of bots, is it not? Badminton playing robot or a soccer playing basketball, and problem statements are given which is favoring whom. Actually these are all run by cheap Chinese businesses. His entire ecosystem is flawed. This is a big racket which is running in the background. If this talk is going to be an eye opener for you, it ends up with your UG and PG. It should end up as soon as you start your UG and PG, it should have stopped winning a few intercollegiate hobby competitions or your final year projects. It will end up there. In your lifelong, you will never, if at all you go abroad and do higher studies, or maybe you go to any industry, start doing these kind of projects, definitely you won't look back to these models anymore, and it will become a garbage for the school too. They cannot demonstrate. Few of them won't run. If at all it runs, it is not worth than participating in next competition which is of same kind. Okay, so it doesn't bridge the gap and cater to industry today. If at all you just Google around internet and just Google out and see what industry is all about when they talk about robots, nothing of this kind will appear at all. So what we are doing, where are we wasting time? They look so clumsy. Anna, if you agree with me, I don't know. If I am not very harsh, they look like toy. So what you are doing,
Yeah,
right? Quite true. So this is what you, so you ultimately what you remain isolated from industrial systems and industrial challenges which are there in the industry. You don't go there to throw a basketball in a basketball court, right? You don't go there to play badminton. Definitely it will do some tinker in your brain. It will create some sense of making things, that is fine, but you don't actually have learned the tools which are required actually to do that in the industry. You have managed to do it, okay, and you have wasted a lot of money. So what India cannot afford now is to make dear robots for entertainment, fancy research for publications which lead to citation, nothing more. Hotels as a food serving robot, or any kind of Sophia also. If you know Sophia, she was given citizenship
yes, sir.
of
Dubai, man.
Dubai man.
Dubai.
She was also given citizenship, passport. It's a mockery on robotics basically. It's just a speaking robot in the background. It uses some kind of AI or chat GPT and answers your queries, and they are done with that. It was just a publicity gimmick for UAE to transfer all the tourism, right? That is always there. Big countries with big money, they will keep doing this, but don't just blindly follow them. We cannot have that fantasy with our government's money. India is not that rich. They are not spending that much of money into robotics, right? You cannot afford to play guitar with a KUKA robot. KUKA robot is there at many places, okay, even in the industry, sometimes in the academics. So that is something around 25 lakhs it starts. And if my student comes to me says I want to play a guitar, definitely it is not meant for that purpose. Probably I could have allowed, if I have hundreds of robots, few of them I can spare to do that. So even this as a project I have seen as UG at IIT Delhi. Got it? When they had just two robots. So this is the pathetic situation. We cannot afford to do this. India cannot afford to do this, right? Deer robots. It is commonly known as deer robots. Out of 5Ds that robots should do, this is the last one which has recently got introduced. And we started using robots in the hotels, in the conference, to distribute pamphlets, to interact with people and all. Right, so that's a funny thing actually, and people invest lot of money on that coffee making machine and all. So don't come up with those fancy ideas. Try to serve the industry. So where is our industry now? What they need? This is another example of KUKA robot video which is there on internet. It tries to tune in a glass bottles, a lot many wine glasses, plays a tune around that, right? So that again India cannot afford. That is good for Germany. It's a German video, fine. But this was Indian. Okay. So robots are supposed to do 4 Ds only, not the fifth one, that is dull, dirty, dangerous and difficult tasks. Which work is dull task? A repeatable task. Whole of the day an apprentice in the industry may be doing one particular wheel tightening. Bolts, he is tightening bolts of a wheel. Right? 4 hours a shift, maybe 2 shifts he is doing a day, and that is a dull task. Dirty may be garbage cleaning robot. You want a garbage cleaning robot to do replace human who is actually doing it. It is dangerous also. Dangerous task to defuse a bomb, maybe to defuse an IED, to face army army's location in the front. Difficult task to use payload capacity robot. If it is there, it is good. So these are the 4 Ds that we look for. This is one instance when I have been to Bokaro steel plant again, and this is not a video from that, it is from internet though. So I could not record that video. So this is the exact scenario. So it was, let me just brief it now. So it is what this fellow is doing. So there is a bath of molten zinc. Okay, molten zinc over here, and this fellow is skimming this zinc bath. What actually is happening? There is a plate which dips inside this zinc bath and it is risen up. Okay, it is a galvanizing plant. So a tin sheet is dipped into this bath and tin sheet is raised up. So that surface of the tin sheet gets picked up by these small particles which are there floating on the surface. These are oxidized zinc. Okay, so this is what he is doing, is skimming operation so that the surface remains smooth. You see, this person is donning a fire suit. This area is very high temperature area. It has got zinc vapor which may be carcinogenic also, and he does it for 4 hours a day only. This shift is not 8 hours a day, and that's a manual work which is happening at Bokaro steel plant. There are many other steel plants who are doing the same. This is everyday's job, I tell you. And you know, this person cannot remain here for more than 6 months with 4 hour shift every day, because he may have inhaled so much of zinc vapor. He is unfit for his life. So that is what is a dangerous task. Is it not? So this is a steel plant's routine day-to-day job. Next similar job is maybe this one. So how it happens in POSCO company, steel company, it is done by robot. Same skimming operation is done by an industrial robot which safely does it. So this is what human replacement is all about. When we talk about robots, they are going to replace human. It is not AI which is replacing human. Okay, that type of human replacement was not desired, but definitely this is desired. So you have to choose, right? So where you have to go for human and where it should be not human who is standing there, right? So next similar job is a sampling job. Again, pouring a ladle, and this person with a huge scapula is trying to pick up a spoonful of molten steel, and he wants to take it for XRD analysis to get the composition, whether how much pure it is or what is the composition that we are delivering with every ladle that we pour. Again, fires to suit and huge amount of vapor, high temperature, fumes, your visibility issues, and it is very dangerous. And people are standing there doing their job 4 hours a day only. Okay, and again this is very bad. And you see it is done by a robot, which is covered robot, again abroad, again at Bokaro steel plant and any other sale plant. This is a similar situation when we have a dump trucks mines at Dhanbad only, where I am staying. Okay, IIT Dhanbad, 5 kilometers from here, you will find this kind of used trucks. Okay, and we are happy, yes, we have this truck, Komatsu truck or Caterpillar trucks, huge trucks. Normal truck is standing next by, you see how big they are. Okay, and these are run by humans, and there are drivers place who are trained over here. So too much of risks is involved. So Caterpillar, they come up with a cockpit kind of trainer who does the job of training these kind of drivers. They are not supposedly to be put on the real trucks and trained, right? So these are the training stations, which are robotic stations where people are trained how to drive such trucks. And in Japan, Komatsu is the company who has automated it thoroughly. You don't see driver seat here. Before autonomous cars saw the day, this type of trucks have already seen a day at Japan, at Australia mines, at China nowadays. Okay, so this is already in use. These are humanless, remotely operated, autonomous driving haulage trucks. So that is already in place. So this is the situation, and what India is doing. We are busy making fun out of entertainment, out of robotics funding, research paper publication and all, right? So I don't say you should stop doing it. So robots are not meant to do that in India. What India needs is for dull, dirty, dangerous and difficult tasks. So this is a Daksh robot which is made by DRDO to defuse a bomb, IED and all. This is UAV Netra, which is used for cross-border surveillance, again made by DRDO in collaboration with IIT Bombay, right? This is a human, you see, he may be called as a Murga, right? He stays on top of the vehicle, moving vehicle, and shoots the enemy, whereas others are sitting inside. He carries the troop of enemy, troop of soldiers, right? So he can be easily captured, right? He can be easily killed, this fellow who is peeping out. So there can be a provision where you have a vehicle which is down below, which can be roll, pitch, yaw oriented, and it can be telescopically controlled from the driver's seat, or maybe some periscope is there to see that. Okay, and you can do this operation without human being here. Okay, but India is not in a case, right? You have RAF Jawans who does this job, Rapid Action Force Jawans who do this job everyday basis, right? There are sewage cleaning robots which is already come up at Chennai some space. It came in Times of India, so I have taken it from there. So it's a garbage cleaning robot. So doing this with a robot definitely enhances the human capability to do this kind of dangerous task, definitely, and it is not meant to be done by human anymore. Okay, so country with not even half our economy like Malaysia, Indonesia, Singapore, they are not using human to clean their garbage, and we are still doing it. So this is a startup which came up with this idea. They are making it, but yes, it has to be scaled up very fast. Government should take this in priority basis, and spread all across India. It will preserve the human dignity actually when it comes to doing such tasks. This again is the center picture down below is a master slave manipulator, which is at BARC Mumbai, where a master slave kind of robot is there to handle radioactive materials. There is a glass screen, again radioactive shielded glass, yellow one. From the person, he peeps from there and he does teleoperated robot inside the hot cell and manipulates the objects. So these are a few applications what India needs, not an exhaustive list though, you know many. Diwali is coming, you will see Roomba cleaning your floor, mopping your floor in just 11,000. So how did this all happen actually? Somebody has invested huge amount of research, money, time, right? And then it came up. We need to invest it there, right? So this is the thing that we intend to do. So how to do it first of all? So you should start with engineering practices with alternatives, right? If at all you are using jumper wire, those are very unreliable. So what you can do, you can make your own jumper wire. You can buy these wires. You just create a list. I'll share this presentation after this slides, okay, and ask the host to share it with you all. This is the list of equipments and practices that you should start with. These are good engineering practices to make any project, not just robotics. You know, not even a single thing which is complete without electromechanical thing nowadays. And it requires that. You don't see even automobile, which was purely IC engine driven earlier, is now using these kind of wirings, no? So create your own jumper wire, know the color codes, follow them properly. There are different strands, 1 meter square, 1.5 meter, it should be square mm. So maybe the picture is wrong. So yes, so square wire, and so those kind of wires you can buy bundle of them. It is used to wire your house electrical wiring also. You know stripping tool, but you should know this crimping tool as well. Center red one. And these are known as thimbles or sometimes known as lugs, are widely used in the industry. You just need to put them on one of these wires, crimp it and make your own jumper wire. Right. This is to be screwed to your screw terminals, which are shown here. So these are screw terminals. Can you see my mouse? Can you see my mouse?
Yes, sir.
Good. So these are screw terminals. Okay. So maybe I can make this a laser pointer now. So this is the screw terminal. Okay. So where you can plug in these wires so easily, and they are very reliable. You can hang in almost around 5 kg with a simple wire, and it won't come out, it won't break. They are reliable copper wires, not like your jumper wires. So it is also possible to buy something around 1 square mm, and there are thimbles for that as well. Okay, so wires can be very lighter also. It is available online at various online shops. So you may buy this and use this from now and on. Okay, so thus remove those 5 things that I mentioned initially, right, from your life forever. If it is your lab, take it out of your lab. Don't let it in. Okay. PCB holders. Don't use double-sided tapes anymore. Maybe you can use DIN rail adapters, DIN rails. Behind you see there is a sheet which is known as DIN rails, okay, on which you can mount PCB, and it is their industry standard. And PCB holders like this, small plastic thing, sometimes you can get it 3D printed. Okay, 3D printers are there nowadays. You have PCB stands where you can put your boards, and the top red bordered one is a product of my company only, which allows putting in your standard Arduino board, plug it in and use these screw terminals and use these kind of wires directly to be tightened here to these screw terminals. And that makes it very reliable connection. It should not use any jumper wire from now on. And then it can be mounted on DIN rail also. So this is a DIN rail mount with screw terminal adapter for Arduino boards. So this supports Arduino Duo, Arduino Mega 2560. So definitely you can use such kind of boards which supports your existing tool set to an industry standard, right? So this is Arduino that you are already familiar, you want to use it, you can use it with this kind of adapter boards. And there are many, I have shown some pictures here. This could be the approach to fix your boards, right? Not using double-sided tape. Next comes is the DIN rail. So this is what is a DIN rail. Again, behind this rail now, this laser pointer is showing. It is 0.35 meter, that is 35 mm width, okay, and 7.5 mm height. It is a DIN rail where you can mount different boxes which are available modular in industry, modular boxes which are there in the industry. Even this supports mounting it on the DIN rail, okay. And these are terminal boxes, screw terminals, which are available one by one. All different colors are available to color code your wires, right? These are connectors, lever connectors. There are relays also, which may be mounted on these kind of DIN rails, right? So you see wire in, wire out. So these are easy connectors with quick coupling so that you don't need to solder it. Again, you can have wires with thimbles which can be easily put there. You have sorting connection, the one which is here, which can get into all these holes. You can tighten them up so that wires are sorted. You want to create a bank of plus 5 volt, you can create that. You can create a bank of ground, bank of negative connection. So all these are possible, right? So using these kind of sorting connections, these are industry standard kind of, which supports using this kind of sorting connection. All these are industrial standards, you know. So you try using these in your projects, right? Don't try to solder them just doing sellotape or something like that. Not even engineering electrical tape, okay. So this is how you have to create your own DIN rails, screw terminals, connectors, and put your relays and everything, right? Next comes stacking up your wire. So you already know probably spiral wraps. How many of you have used it? Spiral wraps. It clubs in all the wire together using a spiral plastic tape kind of, and you can bring out wire from in between and it can keep all your wires stacked up. You can have conduits, a huge conduit which can carry huge amount of wires also, right? All the wires needs to be tagged and labeled, you see. So you don't get lost. You have left your project to some end. The next intern may pick up your project from further onwards if the wires are tagged. Just the way we tag our codes, source code in software, same way electrical wirings are there. So all the wires are tagged, right? You use cable tie to tag it further, okay. And shrinkable tapes, these are known as sinkable tapes. So all the names are here. You can just google around and see the videos of that. Cable conduits, cable ties. This is cable gland. You know how to take out wire from your hobby projects. Those were known as tiffin boxes. Now cheaper than that tiffin boxes, now you can buy electrical boxes which are equally expensive, okay. So you, instead of buying tiffin boxes or plastic boxes, go to the electrical shop and ask him for these kind of boxes where you can put your DIN rail, put your connections, put your relays, put your solenoid valves, whatever, and use proper cable glands. So this is known as cable gland, which takes in wire from inside of the box to outside so that it doesn't allow any water or dust to get into these terminals. So that is the beauty of having such thing. Okay. So these are few professional things which you should look for when you make your hobby projects also. So you have to create a discipline now. If I do it, I'll do it in this way, or else I won't do it at all. I don't want to make toy. I want to make products finally, right? So my project should look like a product. That is first thing. Okay. So now, how does the industrial system look like actually? What are the things that goes behind? GPUs, CPUs, they look like this. The one which is this one, Okay, it looks like this. They are ruggedized PC. Sometimes they can carry as much as 200 kg on top of it. They are vibration free. They are can sometimes ingress protected, sometimes dust protected, right? Noise free, and yes, it can work reliably for over the almost around 4 to 5 years guarantee they give, and it lasts for almost around 15 years or so. So that is how they are made. These are ruggedized industrial PCs. Configuration could be the same or similar, sometimes even lower, much lower, but doesn't matter as long as they are ruggedized. It serves the purpose. I'll tell you how later. Okay, these are servo drives, just the way you are using your H-bridge drivers. It is very much similar. It is industrial servo drives which runs all these servo motors. So industry normally they work on servo motors. They are nothing but motors with feedback which allows closed loop to operate. So servo motor, servo means nothing but a feedback operated motors. It can be stepper motor, DC motor, BLDC motor, or an induction motor also, right? You have variable frequency drive, H-bridge drive, or many other kinds of drives. So all these are there. So this is a drive, these are motors. Probably you might have seen it at on any industrial robot, okay? Bottom one is this whole array of thing. What it is? It is a coupler, basically a data acquisition system where you can put in digital analog input and output values from sensors to actuators, or maybe to lights, to digital output, to alarms, to panels, to anything. Any input and output to and from your IPC, industrial PC, is taken place by using such kind of banks of cards. You see, it are bank of cards which are fitted one after the other. This is EK1100 is a EtherCAT coupler. So what is EtherCAT? That is another thing actually. So in industry, you are familiar with USB, you are familiar with serial ports maybe, okay, or sometimes I2C you have used, Bluetooth you have used. Bluetooth is a wireless thing, that is different, but still all these kind of wired communication you are familiar with. That works well as long as your wire length is not more than 1.5 meters. Okay, beyond that it is not safe to use, it is not anymore reliable. Okay, not even Ethernet needs special kind of Cat6 wires to do it, right? And again there is a limited length in which it can operate. So they are not safe, they are not reliable, they cannot carry distances at high frequency to high distance. So that is where industry cannot have it, right? That is what industry cannot have it. You have a sensor fitted at the gate of your industry and it runs to the security office which is placed somewhere around a kilometer away from that. So you cannot afford to have those kind of communication in the industry. So what goes behind is the right ones, the one which I have mentioned, EtherCAT, Modbus, CAN-open, CC-Link. These are all known as field bus communication. They are safe, reliable for long distance communication. Few of them are proprietary approach, few of them are open, right, industry standard, and quite a lot of them are exchangeable also, with the patent being over, or sometimes it is already sold to different companies, and all the industrial devices supports this, not your standard communication protocol. So now you can imagine you become handicapped if you are trained on serial ports USB to program your microcontrollers. You are going to see altogether a different face in the industry, right? You won't no more be called as a robotics personnel. Maybe you are a secretary, president, vice president of your robotics club, doesn't matter. You are nowhere when you go to industry, and your UG, PG, PhD is not fulfilling this gap. That is the problem. So what is here is a PLC. I don't know how many of you have used it. It uses ladder logic to program it, and you are comfortable with Python, that is fine. But yes, industry doesn't use that. So this is again a PLC, which is a kind of microcontroller for the industry. A set of sensors which doesn't look like MEM sensor that you were using. All these are inductive, capacitive, right, ultrasonic rangefinder, and piezoelectric, maybe strain gauge kind of sensors, right? These sensors you are not heard of. You haven't used it. Voltage levels are 24 volt. They interact with different communication protocol, right? So you are not acquainted with industrial systems, industrial robots. So what you are going to see the next day you pass out from your institute is going to be a nightmare for you. Your engineer, senior engineers will be after you thinking that they have hired a personnel from robotics club and you end up doing nothing for first year at least, right? You will require a lot of time to get yourself acquainted with this. If at all your institute has these facilities, even in electrical department doesn't matter. Sometimes I have seen even electrical engineers, electronic engineers are not familiar with this. This is not industrial electronics. These are devices. We have to learn how to use it, right? Nothing called as electrical, electronic, or maybe a mechanical stuff here. You cannot make machines if you don't know this. Straight as that, right? So you have to pick up as soon as possible, drop Arduino boards, drop those 5 things that I have mentioned, and start picking up this and start afresh. Your life should not be ended up with the school level entry that you have seen in science exhibitions. Your UG project should not reflect the same skill set with a better challenge, maybe. That's all. Okay. So take this oath and you do it. Okay. So this is how typical industrial systems are rigged up. You have IPC, you have HMI, human machine interface, or a display device with a touch screen maybe, right, which runs a SCADA input and output, which is nothing but a GUI in common terms, right, with a display with a touch screen and GUI. That's HMI. You have industrial PC, just like our PC. It also runs with the UPS for safe shutdown. It communicates with the coupler to rest of the boards. Boards can be IO device, can be filter, can be input, output, analog, digital, or can be a motor driver as it is shown here. This is H-bridge driver EL7411. So this is a typical layout of an actuator control system or a data acquisition system. Okay. So this is how it is going to be in the industry, right? So I have just made you aware just now how different it is from a school day to a industry day. So this UG worth what you are doing. Okay, so you have to fill this gap. Until unless you do this, so if at all you are setting up your lab, try to get these materials. Okay, robotics is a costly business. We are already spending a lot on fancy projects, so rather invest on these. They are not expensive. I will tell you now, these IO cards as compared to NI data acquisition device is 1/5 their cost, and it can work much better with open source. This Beckhoff EK 1100 costs something around 9,000 to 10,000. If you take a similar EtherCAT card, not even EtherCAT, Ethernet or a USB based data acquisition system, it will cost you more than 50,000 nowadays, the most inexpensive one. And that is what we are using in academics. USB data acquisition system of LabVIEW or National Instruments costs so much, and this is just 10,000, and it can do communication in gigahertz, closed loop gigahertz. It is EtherCAT secure connection. It can attach digital input, analog input. You don't need any compact DAC chassis if at all you have used it in research, right? So industry is not that expensive. So this is not even expensive. So what you might be thinking, these are so rugged, this must be very expensive. Actually not. In education, universities are very much wealthier nowadays. You know, they are funded. Industries, they run by their own money. So that is the reason they are cheap, right? And they do things in much better way. So just look at the price. If at all you pick up any such device, I'll name a few, and then you just find out the price. I have been doing it since long time. This was a awareness for me and many others today, right? So you can use such device to replace your traditional data acquisition system which you are used to while you were doing your degrees, UG, PG or PhD, or sometimes even faculties. So what happens, as because we don't know this, we are trapped in with marketing guys. Okay, you use LabVIEW and you use NITK acquisition system with this software proprietary locking. Take this license of 5 lakhs worth. LabVIEW is 5 lakhs minimum, bare minimum license, and for this you can even run with free Python source to communicate with external devices, right? So you are locked into because you are not aware how industry is running. You think industry is running with actuators that you use, with systems that you use, with data acquisition systems that you are using, that you are trained on. No. Okay. So they cannot, because they cannot afford to. Academics are rich. Okay. So now, hope you know this now. So yes, that is where is the difference between academic system and industrial system. This is a brief eye-opener comparison. If at all we talk about workstation, desktop PC, we don't talk below workstation nowadays. As if we are going to play a game, a video game, right? Definitely we can do both on a workstation, but industry runs on ruggedized industrial PC or customized embedded systems. So we don't want any workstation PC to make our robot. Got it? After it is designed, you don't need it anymore. Okay, even to design maybe 1080 NVIDIA RTX should be good enough. So don't ask for 4096 NVIDIA RTX, a i7 PC or i9 PC with 64 GB RAM. Right, I'll tell you, don't worry. I know quite a lot of you don't agree with this. Okay, so ruggedized industrial PCs, they have now still running on Atom PC, Atom controllers, right? Celeron controllers, Pentium controllers, Pentium 1, 2, 3, and still it is on. You know, industry has not left it. Still, i386 system, and sometimes Intel i5 chips are quite common. Highest PC will be i5 which you see in the industry, because they run dedicated system with closed loop, fully under control, right? They are operating not on Windows OS. They have some proprietary operating system or Windows IoT version, not Windows 11 or 10. They work with real-time OS, VxWorks layer, like Keel RTX, Lynx OS, MBOS. So these are some of the real-time operating systems which can ensure your timestamps while you are running your systems. You can make CNC machines which can run at 2 meter per second. You can make robot which can run at 2 meter per second with this real-time OSs. So what we prefer is Windows and Linux, Ubuntu version, right? Or maybe something better, you know it. Programming languages, we prefer doing MATLAB, LabVIEW. If it is for hardware, we prefer these two. But yes, definitely you are good at ROS, Python, GUI, C++, C or something, right? Or Java at the most for the GUI. Okay. So that is what we are comfortable, but industry uses ladder logic, proprietary SCADA, Siemens, Rockwell, ABB, Schneider, immersion based SCADA systems, C++ with GUI, fully custom built, not ROS based framework, fully customized one. Python, OpenGL, backend, you can have Python to integrate with hardware's APIs that these drivers support, industry drivers, with front end made up of some OpenGL or something, and they can manage things with standalone PCs running a huge system. Got it? So approach is different, you see. Okay, the way we are trained on these tools, but actually we have to exist here. Windows, Linux, it goes to some proprietary or some other version of Windows. Data acquisition system, we are trained with National Instruments, Avantech, A-Data or something. But industry runs on back of Siemens, Rockwell, Schneider, ABB and their respective application programming interface, which you can use to communicate with these devices. And they are faster, safer, long distance and secure communication at high frequency. Better than this. Power supplies, we use regulated high-end supplies with current and voltage control, but industry uses dedicated SMPS. They are very, very cheap. Regulated power supplies can go in lakhs, these may be in thousands. Okay. Embedded or MEMS sensor, you are used to it, but industry uses ruggedized sensors with IP and other ISO certifications. There are few instances where these may be little expensive, but you should be trained on that. Industry should support, your institute should support using this kind of sensors. Little bit expensive, not much, but it is one time expenditure. We are already doing fancy projects. Okay. Actuators, we use DC motor, BLDC, bipolar stepper with gears and optical or magnetic encoders. Industry uses three-phase AC synchronous motors for precise VFD based control, BLDC motor, hybrid stepper, not unipolar or bipolar, with gears such as harmonic or cycloidal drives and encoders or resolvers. Things are very different. They are integrated in a different way to your programming. Got it? Programming anyway was different. Now the hardware is also different. Communication protocol, you were trained on I2C twin wire interface, two wire interface, USART, universal synchronous asynchronous receive and transmit, commonly known as serial RS-232, 485 standard, serial peripheral interface, SPI or I2C, USB protocol we are using at the most three, but industry runs on field bus. These are a few, I have already named it earlier, right? Simulation. This is something to be thought of. Why do we think that we should always simulate before we make it? Okay, we prefer doing Copella sim, right? Virtual robots we do in that. ROS, Gazebo or Arviz simulation we do, we prefer. I have seen my interns, they do quite a lot of stuffs in Gazebo and Arviz, right? But when they are given a real hardware in their hand, they hardly can progress. Whole month will be passed on just getting one motor running at velocity control mode. Got it? Trajectory following or something like that. Robot decay, yes, it is applied to industry also, but it is here also, fortunately. ISEC sim, this is a huge eye opener which is started with NVIDIA. Chinese robots are using it quite a lot. ISEC sim, lot of you must have heard of it. I'll talk about this also. Publish, compare and get out of your UG or PG degree. Get paper, get published, get degree, done. No products, nothing. How industry works, in hardware first approach. Make the things first using iterative proven design thinking. Iterative design process is an iterative thing. Make it, experiment it, fail it, remake it, right? Keep on improvising things, right? And fully product focused. It should be economical at the end. It should be sellable. It should look good. It should look like a product, right? Your papers are not important. Data sheets are important. Data sheets are important, right? Technical data sheet. Have you ever have an habit of seeing the data sheet of the devices that you are using? If I at all ask which microcontroller is sitting on Arduino Mega board, few of you know it. It is Atmega 2560. How many of you have seen it, seen the technical specification sheet of it? What megahertz does it operate? Yes? Anyone? What is the frequency of that chip? Arduino Mega board, what is the frequency with which it can operate? Who is the manufacturer? How many million instructions per second it can handle? What is the flash memory size of it? What is the bootloader sector size of it? Is there a bootloader first of all? What is the minimum number of components which can be fitted to that microcontroller to make it up? So data sheets are important. So hardly few of you could answer this question. This is pathetic. That is what is happening, right? So data sheets are important, not just journal papers, compare result, get the degree, right? So this is where academic system is failing to cater industrial systems, right? And that is where why you have been asking these questions to your teacher, to everywhere, why India is not making robots, because we are not interested in any of these, right side of it. Teachers are not trained. We don't have university system which caters to these answers, right? So that is where is the gap. We are school at the school level. We are still at the school level. We want to pass out with the same skill set. We are lazy now, right? So that is what. So What is the ISEC sim? Look carefully. System requirements. It is came up with NVDI. We were flying rockets before NVDI was even born. You know that. And they claim without ISEC sim you cannot make a quadruped robot. They provide a minimum specification of AMD Ryzen 5 or Intel iCore i7 Gen, 7 Gen minimum, right? 4 cores, 32 GB RAM, normally much more than what we normally have at home, right? I have it 16 GB, I am doing quite a lot of stuff. They tell no, you have to start with 32 GB RAM, 50 GB SSD, right? GeForce RTX 4080, you should start with 4080. I have not even started with that. I am making products. 16 GB virtual RAM, VRAM. You see, and this is minimum. Good is this, and ideal you can not even think of. The system itself, this one will cost you something around 4.25 lakhs, 4.5 to 5 lakhs to get this system. You cannot even start. So it is for whose benefit? You you must have got the answer in the background is it is all marketing gimmick. They have to sell their NVIDIA Pro card, is it not? That RTX Pro 6000 is very poorly documented, 5080, 4080. They are sometimes not supported by other ecosystems like SolidWorks or maybe ANSYS. ANSYS won't support GeForce RTX 4080 to do model simulations, right? So if you take a card for this, that doesn't worth, it is not worth for some other softwares. So why is it existing at all? It is all a business. It is all a business. Try to understand. It is happening behind. You are run by Chinese businesses for school hobby competitions. Now you are run by US. This is NVIDIA to run your UG business. So ultimately you are never governed by your own. You have not thought how we are flying rockets to space without NVIDIA, right? So we were flying rockets even and NVIDIA was born even before that. So don't think without this it is not possible, right? So what is the way out? So yes, how do I make robot? First of all, you see the way I have rigged up the wire. I don't know if I can zoom it. So if you can see this, so it has same Cytron DC motor drivers fitted on acrylic bolted to them and fitted on DIN rails which you can see through over here. These are three Cytron DC motor drivers. Each one of them can run two motors. These are cable ducts which passes my wire from inside of the cabinet to outside. This is my Arduino Duo board which is held on a DIN rail holder with screw terminals. All the wires have thimbles. They are tightened on screw terminals. You have power bank. You have standard SMPS. Gaming SMPS is quite good, right? So I have used that to generate 3.3 volt, 5 volt, 12 volt, minus 12 volt, right? All voltage levels are available in this SMPS. Mind it, for all projects you can choose such SMPS. These are very, very inexpensive. Available from 500 onwards, depending on wattage, right? So CPUs have seen the day. It has already evolved over the years that uses SMPS, and without using much of the wires you can get at least 12 volt, 3.3 volt, 5 volt easily with very good high ampere. 25 ampere current with 5 volt is available with this, with 250 volt, 250 watt SMPS. Okay, so these are Saturn motor drivers, Arduino. This is a standard board, Arduino board. So you see, this is how we made a 6-DOF controller for one of our robot that we delivered to IIT Jodhpur. These are industry grade switch, NONC contactor elements, right? This is fitted at the board top. Okay. So these are the switches. This is how it looks like from outside. This is our 6 degree of freedom steward platform bot, which is water jet cut, milled, welded, CNC hold, right? Painted with powder painting, right? Adusa logo was fixed and it was running, looked like a product. And mind it, I have used the tools that I have talked so far. And this is my product. This is first. This is almost around 50 kg payload, but yes, they were needing not more than 15 kg and it could handle that very well. Next one is we made it for IIT Madras. This uses industry grade. Again, DIN rail you see, you have terminal boxes, you have MCBs, you have magnetic contactor, right? You have relays here, sitting relays here on the DIN rail, right? This is SMPS 24 volt supply. These are 6 servo motor drives, VFDs basically, variable frequency drives for my AC synchronous motor which is there, right? And these are all the switches that you can see outside: emergency stop switch, push button switches, knob switches are there, fan vents are there, that is for fan, and finally it again look like this. You see, this is tall standing like this. You have all the motors which are here. These are industrial servo motors with encoders fitted here. Linear actuators, fully customized, made in India from Genetics. This was again custom made. All the plates are water jet cut and holes were done by CNCs. Okay. Top plate again single plate water jet cut. Okay. These blocks, pillow blocks, all these blocks are CNC milling done on that, right? And then you have jimmer, that is a spherical joint which is on the top, linear joint here, and that is how it was made. Got it? So this is how we made our product here. Got it? So you can make products with the tool sets, with the industrial levels tool sets only, not with any Arduino or those kind of wiring, those kind of tools, those kind of relays. So I started making things long back. So I had an habit of making things with industrial systems. That is what has led me here. If at all you are aspiring to make your own company that makes such things, not just robots or anything, right? Even to make a fridge, to AC, to washing machine or any home appliance also, you will require these skill sets. Okay. So with these words, I think these are the online course for beginners where you can start. This is ongoing course now. Quite a lot of you have taken already. Theories for implementation, 3000 students have enrolled. First 2-3 modules are on this topic only on actuators, sensors, mechatronic approach, how to make robot, and then I have covered installation, commissioning, right, of robots. These things are not covered in many other courses. So that is the beauty of this course. Those who are doing it, good. Otherwise, maybe this course is already available on my YouTube channel as a playlist. I have made all the videos are available. You can watch it. Right? It is the AICTE approved faculty development program course also, FDP course. Even teachers can do it. So this is ongoing for those who have missed it. Next semester, this is coming up. That is collaborative robots, theory and practice. Again, so normally it starts during February. This is last year's one. Okay. Again is a FDP course. This is for collaborative robot. You can take up this next, maybe in January you can register it and get to know these things in detail, right? So tomorrow I have again one talk. So for now I'll end here for question and answer. Just read these lines. Engineering is a discipline. Discipline. Think like an engineer and talk like an engineer, right? Your words, your terms says what you are, how much knowledgeable you are. You use proper technical terms to discuss with an engineer, not like a layman. "Hey, वो screwdriver लाके देना, ये वो करके बात नहीं करो," right? You have to talk. Okay, give me a Phillips screwdriver of so much size, or a open-ended spanner, or a ring spanner. Name different spanners. Name the tools. See and look like an engineer. You should, engineers know what to see in a machine. They don't need to take photograph of the machine. If they have seen it, the copyright has gone. You have to be that much thorough in what you see any machine. You have visited a place, you see what you have to see. Look like an engineer. Don't wear slippers, half pants in your classroom. Right? Look like an engineer. You have to wear helmet, you have to wear belt, right? You may have to wear a headset, light also if at all you are in mining, right? So look like an engineer. Your project should look like a product. Don't get limited by your stream branch. You are a scientist first, right? You were scientist first. Now when you took intermediate science, you were scientist. Now you are limiting yourself saying that I am mechanical, I need not to learn maybe microcontroller or something. You are not learning it, you are just using it. You are not there to make it, right? So you are not, you don't need any electrical engineering degree for that. You have to use it the way you are using your computer or anything. Wiring is nothing, soldering is as good as welding or a brazing, right? Mechanical engineers can do it. Suggested reads, no publications initially. First, the tools or devices that you use, technical data sheet of the devices that you should use that. ISO standards you should know for the products that you are using, right? And product certifications, which actually are required when you want to sell your products, right? So this is what from my side. Any queries so far?